This section discusses operating system deployment using Configuration Manager. Operating system deployment, or OSD, is a challenging part of a system administrator's job. It's also one of the core features provided by ConfigMgr, with great focus and a substantial investment from Microsoft. In this section, we'll introduce the concept of operating system deployment using ConfigMgr. We'll then show how to build and capture a Windows 10 image before deploying it to a new device. Finally, we'll discuss working with device drivers. This video is titled Introduction to Operating System Deployment. In this video, we'll start by discussing OSD in general. What's it all about? We'll discuss the types of OSD scenario and the additional tools that are used to make it all happen. Then we'll get ConfigMgr specific. We'll have a look at the ConfigMgr console and see what configuration is required. Finally, we'll discover some important new OSD features in ConfigMgr Current Branch. So let's begin. So what's OSD all about? OSD is a method of delivering a mass deployment of a new instance of the Windows operating system to compatible devices. OSD is about automating everything: creating the image, maintaining the image, and deploying the image. But it's not just about creating and deploying an image. It's an entire process that also allows you to perform actions before and after the image is applied to a system. Actions before include partitioning and formatting the drive, and BIOS upgrades, for example. Actions after could be software updates or application installs. OSD is dynamic, enabling different behavior based on some criteria. For example, hardware type or location. OSD is integrated into ConfigMgr, allowing you to utilize the most powerful features of the product, including software distribution, software updates, and reporting, all from a single management console. Microsoft has defined 4 Windows deployment scenarios. Upgrade. This involves an in-place upgrade of the current OS to a new OS while preserving user data and applications. New computer. This scenario is often referred to as bare metal or wipe and load, as it assumes that nothing on the system is currently valid and it should be built from scratch or bare metal. This is the scenario we will demonstrate in a later video. Refresh. This scenario involves installing a fresh new OS on an existing system, while preserving applicable user data and reinstalling authorized applications. In effect, refreshing just the OS. And finally, replace. The replace scenario is similar to refresh, but it involves replacing the physical system. Preserving applicable user data and reinstalling authorized applications are also part of this scenario. OSD relies on additional tools to help with the process of deploying the Windows OS. Some tools are optional and some are mandatory. Some are built into OSD. Others are additional tools installed as part of the prerequisite to install ConfigMgr Current Branch. The Windows Automated Deployment Kit, or ADK, is a prerequisite to installing ConfigMgr. It's a separate download and includes the following components. The Windows 10 pre-installation environment, or Windows PE. This is a mini low-level operating system based on Windows 10. Windows System Image Manager, or WSIM, is a GUI tool that builds unattended answer files for Windows. Deployment Image Servicing and Management Tool, or DISM. This is a command line tool for manually servicing and managing Windows and WinPE images. The User State Migration Tool, or USMT, searches a system for user data and settings and packages them into a single archive file, which can then be restored. Sysprep deserves a mention. This tool is used to remove system-specific information from the OS so that it can be used to image multiple devices. The Microsoft Deployment Toolkit, or MDT, is optional, but it provides a unified collection of tools, processes, and guidance for automating desktop and server deployments. It gives additional configuration choices when integrating with ConfigMgr. Finally, Hyper-V is important in developing the process. You should create a virtual lab for capturing images and testing deployments. Don't use physical devices for this. Now, Let's look at the ConfigMgr console and the OSD components. In the ConfigMgr console, navigate to Software Library Operating Systems to see the OSD components. We'll see the driver and driver packages, the operating system images that we will import into ConfigMgr. Upgrade packages are for use in the in-place upgrade scenario. Boot images are used to boot destination computers when you are deploying an operating system. These were created when the ADK was installed. And task sequences, which provide the mechanism for performing multiple steps or tasks on a client computer without user intervention. We'll discuss these components further in later videos. So, what's new in OSD in ConfigMgr Current Branch? Upgrade an operating system from an upgrade package is new. It's a new task sequence type for an in-place upgrade of systems from Windows 7, 8 and 8.1 to Windows 10. Windows 10 servicing is new. This allows you to automate Windows 10 upgrades using the software updates component in ConfigMgr. Windows PE Peer Cache. This allows systems running a task sequence to download content from a local peer machine while in the Windows PE. Evaluate software updates from cached scan results. This is a new checkbox in the Install Software Updates task sequence step. When unchecked, it allows the system to connect to the software update point and download the latest software updates catalog to scan against, determining what software updates are needed. And finally, the TS-UEFI drive variable. This new task sequence variables allows you to customize an OSD task sequence so that the restart computer step prepares a FAT32 partition on the hard drive for transition to UEFI.